Okay, so can you see my screen? Can you guys see my screen?
Yes, yes.
Okay, okay, so that's good. So, once again, good evening, everyone. And uh, the last two sessions we have had so far has always been around PVT. Then, today is the day we are going to have more like a practical session, and I'll just walk us through it. And the idea is that after I'm done doing this, I most likely share the Excel workbook with you, then give you some assignments because of time. I may, if for the case of modeling, I might just do like two models, right, or two correlations. Then the remaining, you are expected to do it and share with us, especially your insights from uh, uh, the general group. Okay, so today, the idea is simple. I'm just going to walk us through a typical PVT report. Okay. Uh, then, after walking us through that, we'll now start extracting the data. After extracting the data, then we start correcting them, right? And I believe that any theoretical uh, background regarding why we need to do corrections, regarding why we need to do matching and all of that has been effectively discussed in the previous videos. So just to save time, I've just dwell more of what we need to do, which is the data extraction, correction, modeling, and matching. So if I'm able to cover that today, then just know that uh, we have actually done justice to this, right? So this E4000X reservoir is a typical name. It can be any reservoir name, okay? So this is like a conceptual PVT report that contains typical PVT experimental results. So when you come across PVT reports, there are chunks of information in it. It's even more organized. This one is 3 pages. When you see a typical one, it can go as long as 20 pages containing different subsessions that will be captured in a table of content. You have different visualizations and all of that. But for the purpose of our class, I had to narrow down the scope down to the experiments so that whenever you see any typical PVT report, no matter how complicated it may be, you just look out, you just go ahead and look out for these experimental results. Okay, so when you see a typical PVT report, uh, there are three experiments. I think we have discussed about them, right? So there are majorly three. So their results are usually this way. Okay, so for the first experiment, which is captured in table one, we have it to be the constant composition expansion data, right? And this data is usually made up of the pressure, right, the relative volume, the Y function, the density, the compressibility. All these things are results from the experiment that has been done. But one key thing you need to know is that in constant composition expansion test, that CCE data or test, what we are interested in knowing is our saturation pressure, right? That's why whenever you see the report, there must be an indication. It can be in form of an arrow, it can be in form of color variation to indicate to you the saturation pressure. Then another one they equally indicate, either you see it in the table like the way we have now, whereby the reservoir pressure has been labeled here, right? It can equally come in form of like an explanation within the text. They will not mention the reservoir pressure, but those two things are key things that you need, right? Then under it, you usually see a kind of explanation describing what each of those columns are. There are some information under the table that can even contain the equations that were used in determining all of these things. So after you see that one, you are meant to see some series of visualizations and all of that. Okay. And remember, the people doing the PVT experiment most times are usually the third party, right? We have different companies that are or different vendors that do that. So depending on their agreed kind of format, you can have those different visualizations to visualize the uh, the data they have. And as a good petroleum engineer, your eyes, whenever you see those plots, your eyes should go using your already known standard trends of RS, BO, BG. When you look at them, um, compressibility, when you look at them, if anything goes outside that, you can now try to query what is happening there. So the next data you can have is the differential libration data. If you observe, uh, there was equally an indication of the reservoir pressure here, red. Then you see some pressure points above it, right? Then because it's differential libration, our endpoint is usually a standard condition, which is 14.7, but approximated to 15. Okay, so that's basically how they usually report it, right? So this is typical. There might be some changes. Then for another key experimental results you may most likely see is the separator test data. So that's where you see the different stages, whether there are cases it can be multi-stage, like this one you are seeing now. This is a typical multi-stage. So you are seeing we have up to 4 stages, but the first 3 stages are actually the separator conditions, while the last one is at standard condition 15, right? And there's some key information that have been specified here, which is the separator formation volume factor um, taken at saturation condition. So this our bubble point pressure at standard condition with respect to separator. Okay. Then you have the total separator gas oil ratio. All this information are key. We actually will be making use of them, right? So after seeing this, there are some other table you can have things around molecular experiment, molecular composition experiment data, whereby you are seeing the individual components of our fluid, our crude oil. Then you are seeing those C7 plus, the impurities, nitrogen, and the likes. You see them with their various mole fractions and other um parameters, eccentric factor, and the like. So depending, but those ones are very key when we are doing compositional modeling, right? So let's just go ahead. So at this point, I will just be bringing out the Excel sheet, right? So I have already done the extraction. So when you are doing yours, even though I will be sharing this with you, but it will always be good just go through it and actually validate what was done. So looking at this now, you just see it, just have a glance of it, right? So this for the CCA. Then if I go over to the PDF and move over to this, you are seeing you are seeing the CCE result. So everything that is inside here have been extracted into this Excel. And how we do it is that it's always a good practice while you are working with Excel to always arrange your information so that your data you're analyzing has a storyline. Okay. And why it's always good to arrange and have good arrangement is that you wouldn't want a situation whereby you are playing with you are playing with a case that you can't easily debug or actually discover where the error is coming from. So it's always good to arrange it this way. So as you can see, I have used this to indicate the saturation point, just this red one to indicate that this is our reservoir pressure, right? Then um, so the extraction has been done for this CCE. So each of them that has been extracted, I'll just walk you through the necessary corrections that are expected to be done for each of them. So for our Y function now that we are seeing, right? So we have this y function. This y function is a dimensionless factor that is used to correct our relative volume below the bubble point. And you know why? When we reviewed the CCE experiment, we discovered that at pressures way above our bubble point, the volume of oil is 100% oil. Like the volume of the fluid we are entering into the cell is 100% oil. But as soon as we move from the bubble point down, there is now a kind of appearance of gas, right? Gases will appear, and once they appear, our relative volume now may not really be correct again, because we are no longer dealing with 100% oil. So this y function is something we use to correct. So let me just go ahead and do the correction. So pardon me, I'm making use of a small screen. So all right, so this is the formula for, and this formula was extracted from our known Tarek Ahmed, right? So you can always go there and confirm what we have here. So this is the formula that is used to determine the y function, the ones you are seeing here, and it's gotten by doing P sat minus the individual pressures, right, all over the P, that's the pressure state, then the relative minus the minus 1. Okay, but when you want to do correction, doing correction now, remember what you want to find now is now your virial. So how we do it, there are stages of doing Y correction. There are stages of doing that. The first stage is that you need to make a plot of Y, that's the Y function against pressure. So when you make a plot of this against this, you now fit a trend line on it and get your intercept and your slope. So for this case now, our intercept will be the A, while our slope will be the B, right? That's how we usually do it. But for this our case now, I may not be going through that route of plotting, then doing all that. So I'll just go straight and do it in a more simpler way. So doing that now, I'll just type equal to then 1 plus. So first things first, I want to, okay. So you need to be careful with your parentheses to make sure that everything is in order. So what I want to do is my PSAT, which is my saturation pressure, I will just pick it up here, then lock it. If you want to lock, you just use F4. I'll just lock it because it's something like a constant. I don't want it to be changing over time. So once I do that, I can now go ahead and do minus P. This P now that I'm entering is the individual pressure. So because I'm at the saturation point, I'll still pick that pressure. Then once I'm done doing that, I can now divide. Dividing now, what I will be doing for this division will just be that I want to multiply by, I want to multiply this pressure now by my individual, by my slope, by my intercept plus slope, then times pressure. So this slope now, I'll just go ahead and use our function in Excel, slope, to calculate the slope for me. So remember what I'm plotting um, will be, what I'm plotting will be what I'm plotting will be my y function against my pressure. However, if you observe, I don't have y function at the saturation point. So I'm just going to extend this to, I'm just going to extend this to 10. I'm just going to extend it to 10 so that I won't be having any error. Then my slope now is now going to be the vertical against the horizontal, right? So my vertical will be this, then against this, but just so we know, just need to place this here. So against this, then um, after doing that, I have calculated for my slope now. So what I'm going to do will be my slope plus then multiply the intercept, which the same thing is applicable. I just need to scan this and by this. Then I now have my intercept multiplied by my pressure. Okay, so let's just cross check. Do I have slope plus intercept times this, then this times this, then divided by. So everything should be in order. Let me just confirm one more time. Okay, so I think I should have this. Okay, okay, great. So, uh, okay, so I have a division by zero. I just need to cross check to know where I'm getting that. Okay, so this thing should stop at 14. 14. It should be 14 then. It should be 14. Okay. Okay, so with this now, with this, I'm able to uh, calculate for this, but uh, it seems as though, okay, all right. So this corrected relative volume now will most likely be what we are going to use whenever we are making any calculation for below the below bubble point, right? So, but at the moment, we just continue. Then, if there is need for this relative volume correction, then we can always come back here. Then for this differential liberation, we don't usually make any correction to it, right? We don't make any correction to it. It's just like a chunk of information that we use, like we are going to extract information from, right? But it will be at separator. That's where we are going to make some corrections to. So at separator, we are going to like extract an information, and that information is our gas gravity. And we usually calculate this gas gravity by using the weighted average method. And the weighted average method is represented this way, whereby you have your RSP times your separator gravity, gas gravity, then plus the stock tank uh, GOR, then times it by your stock tank gravity. Then you now divide by the summation of this and the one at stock tank. So that's exactly what we need to make this calculation over here. So if we want to do that, just to still recap here, this GOR from here to here, as we saw in the report, is actually our separator GOR, right? This last one at 15 is the one at stock tank, right? So this gravity corresponding to this will just be from here down to this last one. So what we want to do is that we want to calculate what our gas gravity will be uh, using this formula. And to do that now, we still go ahead and do sum prod. So this sum is just like we want to add the product, right? So we are going to just come here down to this. If you watch, I'm not reaching the end, then comma down to this, right? Then do plus. This plus now will be my RST and YST, right? Which is product. And this product now will be RST, will be this, and this. That's the last one, right? Then once I'm done doing all of these things now, let me put this. Once I'm done doing this, I need to divide now by the summation of this one plus this. So I'll just do sum and sum all of them since they are in the same row. And once I'm done doing that, and I have my gas gravity calculated here. Then for our uh, at this point now, what we now need to do is that, remember, I still gave us some reasons why we need to convert, right? Why we need to actually correct our DLE to our separator condition. So this is how to do it, right? First things first, you actually map out the pressure. Once you have written the pressure, from the pressure information must correspond to your DLE. Then once you have done that, you copy out your VREL, and the VREL you are copying is this one here, undersaturated, right? Then you copy it down to this place. Then our solution gas oil ratio will be the one from your differential liberation over here. You just copy it down to this point. Then our relative oil volume, which is our BOD, will still come from your differential liberation test. Then after doing that, you get your density as well. Then you can bring out other information all from your differential liberation, right? Then to actually do this conversion, like to do the correction to separator condition, we have key information we must bring out, we must extract. The first information we must extract will be our BODB. So I explained this in our last class. BODB is our oil formation volume factor as saturation point from the differential liberation. So we just come over here and look for this is our BOD. So this information now, we just copy it. It's going to be our BOD, right? Let me just change the column to this. So after copying out that one, then we have our BOFB. This is now uh, our BO at bubble points from the flash, like from the separator. So we just go over to this our table and extract it, and you can see it over here. So it's actually this one, 1.265. So and I come over here and paste it. 65. Then our RSDB we still is the one from our differential liberation at bubble point. So we just still go over there and pick it up. And when we pick it, we just come over here and paste it. Then our RSFB will be from separator condition, which is this. So over time, just get used to knowing where you need to pick your data. But for this class now, you can just start with this. Okay, so once we have gotten this, we can now go ahead and make our adjustment. So in making our adjustment for BO, there are equations that are used, right? So in making adjustment for your BO, uh, This one is our above. So you do this from above, starting from this down to here, like above bubble point, while you make use of this other one now, which is the multiplying the shrinkage by the flash BO, right, at uh, saturate saturation point. So how you do this now for let me just start with above. So for above is just a simple case of multiplying your, let me shift this over. So BO will just be a simple case of multiplying your VREL. So you have this your VREL, multiplying it by your BOFB. Okay, so this your BUFB function F4 to lock it up because we don't want it to be changing. Then just run it. Then once you run it, you just drag it down to this point. All right, this will now calculate our BO values for us. Then for this other one below, from saturation point, this the point whereby you need to multiply with your shrinkage, right? Your differential oil shrinkage factor. So to do that, we do the individual BOD, right? Divide them by our BODB, then multiply by our this one. So to do that now, let's just do it as we are saying. So let me start from here. BOFB, BOFB will be this, right? I will lock it up, then multiply it by BOD, which is the individual that you are seeing. Let me start from here, right? Times BODB, right? The BODB is this one you are seeing. I'm still lock it up. Then no, no, no. So uh, BOF. Let me just check it out. BOF, then locked times our D12 at bubble point, then times our C2 locked. And there's something. Okay. So, but these numbers are strange. These numbers are quite strange. They don't represent the typical we are having up to these values. So let me just cross check what we have here. Okay, so at this point, if anyone has any question, please do it to ask. Okay, so that it won't just be as if we are doing more of too much talks. Let me just correct this by okay. So let's do for arrest. Then we need to still come back and know why this is actually not showing properly. Then for our arrest, I think in our last class we made mention of two things. The first one was the one we are talking about, the the case, the case that this person prompted out, the case that I think McCain pointed out. So we have corrected and actual. So for the purpose of our class here, we are going to make use of the recommended, right? The recommended, and there's this recommended that I think I wasn't able to show it in our class, or maybe I did. So look at it over here. So this is the recommended. So that's just what we are going to use. Okay, just a minute. Okay. So to do that now, we are going to just go ahead and do RSD. This RSD you are seeing is the individual uh, RS value that we are seeing from differential liberation. That's now what we are going to use to multiply our, in brackets, our RSFB, right? Then I'll just look it up. Then divide it by our RSB, which is this one. I still need to lock it. Then drag it down. Then then this one we made an assumption that from saturation point, from initial condition to saturation, that we usually assume that gas has is just a single phase. So gas has not started leaving the system. So because it has not started leaving the system, our RS value should be constant all through. So that's why once you are done doing this, just carry this and use it and populate up up here. Okay. So let me just check this once more. So now, so at this point, I don't know if we have any question. Is there any question from us? Do we have any question? Sorry, I can't see our hands being raised because I'm using one screen. Please, can someone confirm that I can be heard?
Yes, yes, you can, yes. There are no constraints at the moment.
Okay. Okay, just a minute because my my battery is low, so I'm trying to see if I can switch my system. Okay, I'm going to stop sharing now because I need to transfer this sheet to another system. Okay, just give me uh, a minute. So let me just go ahead and transfer this to another system.
Okay, all right, everyone. As Praise, our facilitator is working around getting his laptop set up. Just want to reiterate to each and every one of us that the recordings of this class will be provided, and it will be a wonderful step if you go back to the previous sessions on PVT, right? Rewatch them, gain understanding of them, so that when you rewatch this session, you are able to really get the whole scope of what we are talking about. It's possible that there are still people amongst us that don't know what RS mean or that don't know what BO mean. So everything happening on the screen is basically looking like magic to you. I really advise that we go to our YouTube channel. The videos are there. Go ahead, watch them. If you have questions, drop on the group chats. There will always be somebody to respond to you. Only then will all the everything we're talking about here make sense. This will really help each and every one of us to, because you may not see a PVT data while you are still in school, and up until when okay, our facilitator is back. All right, as we continue this session, if you are finding it difficult to get or understand something, make sure you go ahead and ask questions, go back and watch the previous videos and also this one. And I'm sure that you will be able to replicate everything happening here. Have a very wonderful learning session, everyone. All right, sir, please, you can continue. Sir, please, if you are speaking, you are muted. We cannot hear you.
Oh, sorry about that. Can you hear me now?
Yes, yes, you can be heard.
Sorry. So I was saying that I just switched over. Unfortunately, the system I switched over to, the battery is equally low, but no problem. We still push it through. So this we have actually adjusted for BO and RS, but this BO is having issues. Why? We are having BO of 2 points, right? So it's not really following the trend compared to what we have here. So it will be a quick one for us to go through the formula. So this shrinkage is this divided by this. So let me just go ahead and check. Wait. Okay, so this multiplication instead of division. So let's check our D12 will be this, right, divided by this. I think this should solve it. Okay, yeah. So we are good to go. So at this point in time, we have corrected for this, which looks very kind of similar to our what we have here. However, at this standard condition, we are noticing 0.999, right? We wouldn't go with that, although it's approximately one. So what we can do is that I can just go ahead and change it to one, right? Can just go ahead and change it to one since it's approximately 9. Okay, since it's approximately 1, so let me just format this way. All right, so everything should be how many decimal places. So with this now, I'll just move over to the black oil modeling, right? And this is the part that we need to extract more information to. So this in this place now where I have my adjusted BO and RS, I'll just go ahead and copy and paste the information just the same way I have it. I just come over here and paste it. Oh, let me paste as just numbers. Yeah, so I have this information over here. So the next thing I can do now is to fill up this information. I think I have them already here, starting from bio and this accept. So I'll just copy here. Then BODB, then the next one is BOF, which is this. I just need to populate them. So these are key information you need to populate as well. Then we have this. Let me copy this one as well. So we have this information. Then the next thing we need to get will be our oil API gravity. That's equally when we need to go over to our PVT report. And don't forget, we usually get it from our separator. You have it this way. There are two ways. Either you use this to get to enter for your API, or you just come over here and come to this top tank oil density using that 141.5 all over specific gravity, which is what we have here, then minus 131.5. You can use it and calculate your API, but for the purpose of our class, I'll just go ahead and use this 43.04. So 43.04, right? The initial reservoir pressure, that's what we have here. Okay, this one is initial reservoir temperature. So let me just go ahead and paste it here for initial reservoir pressure. So our initial reservoir temperature, let me check if we have it from here. So we have it to be 247. So we are going to have it to be 247. Then the next one we have there will be our saturation. And as you can see, you are seeing our saturation value over there, which is this pressure point of 1420.4, right? Then our gas specific gravity will now be the one we calculated based on weighted based on our weighted average method. Let me go back to our report because I'm noticing something here. What's our temperature here? Our temperature here is 120. Then our reservoir pressure, initial reservoir pressure is not actually that. I think that should be a mistake. So just take note, our reservoir pressure, I didn't capture it here, right? But the value is around, the value should be around 211. So we'll be making use of 211. So just take note of it. Maybe if I will share the report with us, I'll make that correction. So this gas gravity you are seeing now will be that one I calculated in separator. So I will just need to, this G2 and this SP. So how we do it in Excel, we just be equal to SP quotation G2. Yeah, so this exactly I just referenced what is in SP. Then the separator pressure, you get that by coming to the separator. This first one, is actually our separator uh, pressure, right? 120. So just go ahead and write 120. Then our separator pressure 2 will be uh, our separator pressure. Our separator pressure, I guess there's still, I didn't indicate it here, but the value where I extracted the information from is around is around uh, 122, right? 122, or we can still go ahead and take this first one, 140, as the pressure, initial pressure. So let's just take it to be as the separator pressure, 140, right? Then our specific gas gravity. This specific gas gravity, this separator gas gravity you are seeing here, um, we is part of is actually part of the equation, is part of the correlations that we have. So when you see standing equation, either standing or Petruski, any of them, you will see that they will require separator gas gravity. So it's a little bit different from your from your uh, from the normal this thing that you know. So how we can how we can go about it is that we just go ahead and do you just go ahead and do this, open it up. So this, I've actually written a VBA code for this to handle this, right? So I will just equally shows the code, and when I share this with you, you will see it as well. So this gas gravity at separator pressure and temperature will just be this one we have here, right? Then API will be this API value that we have written here. Let me just scan over. This is the API that we have here. Then this, the separator pressure will be, the separator temperature will be this. Then the separator pressure will be, no, will be this. Let me delete. The separator pressure will be 140. Yeah. Okay. So after getting this, our oil gravity will now be this one that we have over here that I made mention of. Let me get our, will be this one you are seeing here, right? Because we usually take it as separator condition. So we take uh, 0. 0.80 0.8099. So I'll just come over here and write 0.8099, right? So with this, I have everything I need to go ahead with my modeling, right? But before I continue, let me just go ahead and see if I can open the code. So what I use, the shortcut I used is alternate F11, right? So these the codes that have been written for this. If you try using function to type these things one after the other, it's going to take you time. It's going to take you time. So I advise you just go ahead and make use of this. Maybe follow the format and write more functions that you need. It will help you so that you can easily debug anything you want to debug. So let me just stay continue. So for the RS for Glasso at bubble point, I just need to type Glasso here. and I'll just click on this function. I will get my gas gravity. Then we need to lock it. Then get my API as well. I need to still lock it. Then get my uh, uh, pressure, my temperature. Sorry, I need to lock it as well. Then get my uh, temp separator pressure. Get my pressure, which is G temperature, then which is this. Good. So I have it this way. I just draw down. Okay, I think this should be the individual because nothing is changing. Oh, good. Yeah, so I have it. So that pressure there is actually the individual pressure and not the reservoir pressure. So this requires you to pay attention, else you may be running into complications. Then for the Petruski, I'll just go ahead and type Petruski RS. So I'll open up this now. Then the pressure will be the individual. Then the gravity now you are seeing will be my uh, gas gravity that I have here. Then I will I will lock it. Then my API will be this. I will still lock it. Then my temperature will be this. I'll still go ahead and lock it. And I have it this way. Okay, so someone raised his hand. Sorry, I can't see. Please, can you go ahead? If you have any comment to make, you make. I
All right. Can you hear me?
Yes, I
So
can hear you,
quickly,
sir.
um, I'm taking a hard stop at 8 o'clock. Have an appointment. So I just want to make these
Okay,
comments to everyone that joined today's section. That I think we'll have to repeat this section again because what we are doing is like a foundation in petroleum engineering. Okay.
yeah,
This week we have interviewed two reservoir engineers for senior reservoir engineering position. And the major questions that they were asked was about PVT, quality checking of PVT, extraction, correction of parameters, and all of that. And I think, yeah, one more class around this will not hurt. So guys, thank you so much. I'll be running right away. Yeah, but for us to really derive value from this, we will repeat this section again and then ensure that everyone that is in this community understands PVT data extraction, all right, and correction. Thank you so much. Enjoy the rest of your time with praise. Bye for now,
okay.
guys.
All right. Thank you so much, sir. Thank you so much. So I wanted to equally make a comment on that because we have another sheet, which the last one, where we are going to have a lot of things to do. So it may take another time. So what I think we can do is that I'll just finish up with this BO and Petruski. Then once I'm done doing it, we can now call it a wrap. So let me still go ahead and finish up. So for Glasso now, Glasso correlation, I just need to come over here and get the RS value, right? And get the RS value. Remember, the RS that we'll be using now will be the corrected one. Okay. Then our YG, which is our gas gravity. Let me just look at this. Is our gas gravity, but I need to lock it up. Then our oil gravity, I still lock it up. Then our temperature, I lock it up. So this what I'm going to use and drag down, right? So with this now, I have my uh, Glasso above and below. Below. Then for Petrosky, I'll just go ahead and do Petrosky. So these are various correlations that maybe in our next session we are going to bring them up. Then gas gravity, of which I will lock it up. Then oil gravity, I still lock it up. Then temperature, I just have it this way. Then I will drag it down. I drag it down. So let me just check. Okay, our temperature, I didn't lock it. So I guess that was why. Okay, so we now have our BO based on Petrosky. So above bubble point or above saturation point for the correlations we have, they make use of one correlation, just as some things usually change, right? So what they usually use is BO. So I will show you this formula possibly in our next session. I will show you this formula, but for this one, what we need to enter will be our BO, BOB, which is our bubble point, saturation point, formation volume factor, and this I need to lock. Then our compressibility value, which is what we have here, right? Sorry, not at that point. Then our pressure, which is the reservoir pressure. Just shift this to us. Okay. Yeah. So I think, okay. It's not the reservoir pressure. It's just going to be uh, it's going to be this pressure. So let me just try it. Then our saturation pressure is the one I'm going to lock up. So let me check something. Okay. So I'll drag it. So this I'll drag down to this point. Right. I just drag it down to this point. Then do the same thing for Petrosky, which is BO above. So these things are key. We are doing it the hard way for you to understand. On a normal basis, you are meant to use a software to do it. Okay, so but that's what you gain. And once you are done doing it this way, anywhere you see it, you are good to go. So I will simply click on this, then lock it up, then get the compressibility corresponding to that and the pressure as well. Let me shift this thing over. Yeah, then the saturation pressure, which I need to lock up. as well. Then run it down. So with this time, I've actually completed the modeling for these two parameters. Then the next stage, which will now be like in our next class, will be where I will be doing the actual matching. So I think that will be another session because if I should rush it now and go through it, it may really not make sense. So today we have covered CCE, DLA, separator, then correcting to separator condition, then doing modeling as well. When we have another session of which that will be communicated to us, then we can have a more interesting class by showing you the equations and relating them to the VBA codes that have been written. So I thought of doing that today, but our time uh, time will definitely be against us. So at this point, I will be stopping, hoping to get questions from us now. So I will stop sharing. So if we have questions, this is the time to ask before we can call it a wrap. So do we have any questions so far? Okay. I can see we don't have any question. Okay. Samuel, go ahead and ask your question.
All right. Thank you, Mr. Press, for this session. So it's a whole lot of information, but at least when we're able to get back and watch the video, I think we'll be able to grab more. So my question, I think, is just a few questions anyway. You around this function of like these very parts we did last, I observed that you lock some parameters while you leave some unlocked. So I don't understand the logic behind that. And also, I was going to ask about all these correlations, the Glasso Petrovsky, the function that was written about it. But I think you just mentioned that it's going to be discussed more in the next class. So I just want to get the information behind locking some parameters while leaving some open. So
Okay. Okay, that's good. That's a very good question. So for the correlations, I think I will have another time to explain it, at least relate it with the equations. Don't forget that in our previous class, we have seen some examples of those correlations, right? So why I lock, to answer that question of why I lock, let me just open this RS, right? So this RS is made up of gas gravity. And this gas gravity you are seeing is this single parameter here. So, and it's a single value. Because it's a single value, I need to lock it because Excel has what we call referencing. Okay, we have relative referencing and absolute referencing in Excel. So, uh, when we lock, as we are dragging down, that value will remain the same, right? And that's what we want to achieve. But if we don't put all these dollar sign or if we don't lock, it will just be taking values like sequentially down, and that will alter uh, our value. Just observe that API2 is a single point data. So we had to, sorry, API is a single point data. We need to, that's why we locked it. Temperature that we have, which is this temperature now, the initial reservoir temperature is still a single point. We need to lock it. But this pressure is the pressure of the system, which is the pressure that we start from here down. So for each step, we are considering individual pressures. So we are not meant to lock it because we need it to be progressive. So just watch. Are you seeing the pressure here, right? If I move over to this one now and open up, you discover that the pressure is now A14. A40, it has shifted from this. So that's why we make sure we don't lock it so that it will be capturing pressure points progressively that way. So I don't know whether that has answered your question briefly.
All, all right, it has. Just for clarity, so it's going to stop at the last value on that sequence. I mean the pressure.
Yeah, it's going to stop
Changing.
at that level. Yeah, because I'm going to stop it
Okay.
there. Then, if for any reason now, I think let me just go ahead and do that still. So let's assume that I reached here, I didn't stop, I kept on dragging. Are you seeing that it's giving me an error, value error? And what is
Yes.
this value error? This value error is that this pressure value that I entered here in 19 is actually empty. So there is no value here. So it's giving me a value
Okay.
error. So
Oh, all right.
that's just the
All right.
idea. All right.
All right. Thank you so much. So
All right.
what you used to lock it
Okay, you
is
lock it.
F4, right?
No function F4. There's a
Okay,
function,
function F4.
yeah, Fn. That's the short form on your keyboard.
Yes, yes, yes.
Fn. Yeah.
Yes.
So you just do it and
All
lock
right.
it up. Yeah,
All
that's
right.
it
And
about that.
and to get to that code page you made mention of, is it Alt F11, right?
Yeah, alternate F11. Yeah, it will take you
All
to
right.
that. However, if it
All
doesn't take you, just go to your developer this thing, then check Visual Basic. You click on it, it will still take you back to that place.
all right.
All right.
Alt F11 does it. So,
Yeah. All right. Now that's
all
great
right.
then.
Thank you so much. All
All
right.
right. So I can't see any other hand being raised. So thank you guys so much for this time. Maybe when we agree on our next session, we are going to still inform each and every one of us, right? So that's all from my end.